Hi everyone and welcome to the third video of the Peer Club R series. Today I will show you how to write your first real R script where we will import data, calculate the summary statistics, and also plot the data at the end. Before we do that, I will give you a short introduction into a few more bits and pieces that you should consider when you're preparing your data for R, and we'll also show you a few tips and tricks that you can use in R and R Studio to just make your script look much, much nicer. So the first part of the video is only going to be based on the slides that I prepared for today. In the second part of the video, we will switch to R Studio where I will be doing some live coding. This time, I'm inviting all of you to just code along with me and pay attention to some small bits and pieces that are important while you're creating your code in terms of keeping the code clean as much as possible and also understandable for you and any other users, and also pay attention to when to use square brackets instead of round brackets, or when to put any terms into inverted commas and similar. Okay, let's have a start. So today I will show you how to organize a script nicely, annotate it sufficiently and keep it tidy, as I mentioned. Then set your working directory or create a project, install and load packages, import your data, using the pipe operator, which I will also explain later, calculate summary statistics using dplyr, which is a really great package from the tidyverse family, export summary statistics, again in a CSV file, and plot your data in base R and ggplot. And today we will only do some very simple plots just to give you an idea how this would basically work in R. Okay, so before we start, I would like to talk about data entry and how to prepare a data set that you want to use in R and work on it. So how we used to work was, for example, that we would have a growth experiment, let's say, with, in this case, I'm going to use the water fleas, Daphnia, because they were my study organism during my PhD. And you have an experimental design that, for example, includes 3 stages. So first is species, where you have 2 different species, in this case, Daphnia pulex and Daphnia magna. Then you have 2 different temperature treatments of 15 degrees and 20 degrees. And then you would have 3 different food quality treatments, in this case, low, which for Daphnia is mostly a mixture of cyanobacteria and green algae, with cyanobacteria being a really, really bad food for Daphnia because they have not only the toxins, but also they lack some polyunsaturated fatty acids, PUFAs, and some sterols, and food qualities, medium and high. So the way you might put your data into an Excel sheet would be something like this. You would have, for example, 2 different data sets basically subdivided for the temperature. So we see here in the upper part, we have the temperature of 15 degrees, and then in the lower part, the temperature of 20 degrees. And then you would have, again, 2 kind of separate parts where you have data for Daphnia magna on the left side, and then data for Daphnia pulex on the right. And for each of the food qualities, you would, for example, have 1 column. And in each of these columns, you would then put a parameter that you measured, in this case, the growth rate. So this way of entering your data into Excel might be an easy way for yourself while you're doing your experiment. However, it's not really very suitable for R. So how your data should be organized is something like this. For example, we have this first column with the 2 Daphnia species, then the second column that has the temperature. And you see here that we first start with Daphnia magna and first have the temperature of 15 degrees, and then we go to the temperature of 20 degrees. And then everything is again repeated for Daphnia pulex here. And then you have these 3 other columns, each of them representing the growth rate in one of the different food quality treatments, being low, medium, and high. Although this is still not perfect, it is definitely much, much better than what I just showed before, because you have everything in columns. There are no empty columns, there are no empty rows or empty cells. And everything else that we have to change here can be either done really quickly in Excel, but also we could do it in R. So if your data looks approximately like this is already fine. And all the other reorganizing of the data can also be done in R. So before we continue, I would just like to again explain some of the terms that we commonly use in R when we talk about data and how the data is structured. So for example, when we're talking about observations, we're talking about rows. So each row is supposed to be 1 single observation. When we talk about variables, what we mean are the different columns. And when we talk about the values, we're basically talking about each of these cells here. Once you uploaded your data into R, very important thing is to check its structure, just to check if everything was imported properly. And if not, usually the case is that you have either chosen the wrong column separator, which in most cases should be the comma, especially when you're using the comma delimited CSV files. Or for example, for users that would have an Excel that uses the comma as a decimal separator rather than a dot, this also might cause a problem while you're uploading the data if you, for example, forgot to tell R that actually your data is separated by a comma rather than by a dot. So all of these things have to be considered, and just check your structure before you continue with your data analysis to just make sure that all the data types are correct. If you encounter the problem with a numeric variable being a factor, just keep in mind, as I said before, that you first have to query this factor into a character variable, and then from character queries it into a numeric variable. One other thing that I would like to show again are the different operators that can be used. I already mentioned these before. So we have the 4 different groups here, the arithmetic ones, which is just meant for mathematical operations, the relational ones, such as less than or more than. And keep in mind, if you want to check if 2 things are equal to each other, you would have to use 2 equal signs. And if you want to check if something is not equal to each other, you would use the exclamation mark here and then an equal sign. Then we have the logical operators such as and, or, here, as I already mentioned, not, and so on. And there are the miscellaneous operators. For example, the column here is usually used if you want to create a series of numbers. For example, you start with 1 to 10 and you just want to have a sequence of integers, then you would write 1 and then the colon and then 10, and you would get all the integers between 1 and 10. There are other tips and tricks in RStudio that are very useful, especially if you just want to do some fast coding where you're using some key shortcuts. And some of these can be seen if you just click on code and check on all the different options. And many of these will already have the key shortcut next to them. There are a few tips and tricks that I would usually use. I have added some of these here. So on the left, you can find key shortcuts for Windows, and on the right, you can find key shortcuts for Mac. So for example, as I already showed before, if you want to create the assignment operator, you can use Alt and minus. If you want to create the pipe operator that we will be using today, you can use Control, Shift, and M. If you want to create a new section, you can use Control, Shift, and R. If you want to rename something in scope, so for example, you already gave a name to an object and have been using that name along your script, but now you want to change it to something else. So rather than going to every single occurrence of this object, you can also just use Control, Shift, Alt, and M, and it will basically mark all of the lines where you have the name of this object occurring, and you can just change the name in scope. You can use Control, Alt, and then the arrows up and down to use, for example, a multiple cursor. You can use Alt with the arrows up and down to swap lines. So if you have the cursor in a specific line that you just want to move a line above, you can basically just press Alt and then the arrow for up, and it will move it in the line above. And for a tidy code, you can use Control plus I. What this will do is that if you're writing your code and, for example, you have a few spaces at the beginning of the line, and then in the next line, you maybe have a few more spaces, or for example, you've been writing some loops, and the more loops you have, the more shifted your code will be. But then if you remove some of those loops, you would have to either go back into every of the lines and basically remove some of the spaces if you want to have your tidy code, or you can just mark the entire code, press Control I, and this will then align all of your code exactly the way it should be. There are a few more tricks that you could use. For example, if you're using a function and then you're in the parentheses or in the brackets and you want to find out how this function can be used and if there are any specific instructions or what input this function needs, you can just press Tab and this will appear as a small window. Also, if you are, for example, using the inverted commas whenever you are uploading a file, if you just press Tab within those inverted commas, it will usually show all the files from your directory. So you can basically just scroll and search for your file that you want to upload. One thing that I would definitely recommend you to do would be to create some sections within your script. And the way you can do that is basically by placing a hashtag, which is usually used if you want to annotate your script. So you want to have some comments that are not executed in the console, but are just part of your script. Then you can add some text after that. And then the only thing you have to do is to add 4 characters, either of dashes or the equal signs, or again, the hashtag or the pound sign. And this will then create a section. And I will show later how to assess these sections and how to work with them. You can also use snippets, and you can even create your own ones, which I will also show later. So for example, there is the snippet TS, which stands for a timestamp. So basically what you do is that you just type in TS and then the tab, which will then already show you the option of using the timestamp, and then you just press on enter. And what you get is something like this. So this is just a timestamp that has the day and then the month and the date, the time, and then the year. For example, if you're writing a for loop, there is even a snippet for that, which is just for. And if you do that, it will automatically already give you this basic structure of the for loop that has these brackets here, and then the variable in vector, which will remind you that the for loop will need a variable and a vector as an input here. And also there is the option of finding and replacing things. So you have been using a similar script for different things, and you just want to make sure that you renamed everything properly. You can either use something that I showed before. So for example, the rename is scope, or you can just use find and replace. There's a whole other bunch of tips and tricks, some of which I'm showing here, that are basically including some key shortcuts. So just have a look at that, and maybe you will find a few more other useful options that you could include in your coding. So this is the end of the first part, and now we can continue in RStudio. So hi everyone, and welcome back. I have now switched to the RStudio, and we'll start writing a script, and you can just code along, and I hope you will enjoy this. And I'm going to try to keep it short, but also very useful and informative. So we'll first start by showing you how to set a working directory. That should always be the first thing you do whenever you start coding in R. And there are different ways how to do so. One of the easiest is basically to go to session in your RStudio, then go to set working directory, and then go to choose directory. You already see here that there is a shortcut, which is just Control Shift and H. I think on the Mac computers it's probably Command Shift and H, I suppose at least. And if you just click here, it will basically open the Windows Explorer, where you can search for the folder where you want to have your working directory set. And this should be the folder where you have all your files that you're going to be using within this R session. So for me, this is the Peer Club R series folder, which is already set here. So I'll just open this. And what then happens is that the console will automatically also write the code which was used to set the working directory. I would recommend to basically just copy and paste this code. So you can just on Windows computers use the Control and C to copy it, and then definitely include this into your R script. So to start a script, as you might remember, you go here to new file, open this, and you click on R script, and then you just copy paste this here. Okay. So now we have this very first line, which is basically just setting our working directory. You can also use the command get vd. I'm just going to write this in the console, which means get the working directory, and this will tell you your current working directory here. This might be useful if you do end up changing the working directories within one session to just make sure in which working directory you're currently working. Something else that you can do, which is also really cool, and it's kind of a modern way that allows you to avoid problems which you might encounter if you do not choose the right working directory, is to create a project. A project is kind of keeping all your things together, and whenever you start working in R or you're just about to start, you basically open your project, and this project will have all your stuff inside, your scripts, your data, everything. It obviously depends on how you sort everything together yourself, but it's definitely useful to maybe have that for, let's say, if you're doing your PhD, for every of your chapters or something similar. How to do that is really easy. You just go to this blue cube here with an R in it that says create a project. You open that. It's going to ask you some things. Just go and don't save in this case. Okay, and then this window will open. And what you can choose here is, for example, an existing directory if you already have a folder with all your data, or you can go to new directory if you want to create a new folder where you will be putting all your data together. There is also the third option, which is the version control. And this is something that I will be showing in some of the other videos. For today, I will choose existing directory. Okay. And it already recommends me here to just use the Peer Club R series. And this is exactly what I want. If you want any other folder, you can go and browse and then just look for the folder that you want to choose. And whenever you've done so, you just click on Create Project. Then it takes a little bit. You see this here. And then you are now in your project. The script that I just started writing is gone because it's in the actual normal R environment that is not connected to the project. And if you look into your right upper corner of your RStudio, there should be somewhere the name of this project. And this name is basically just the folder that we have just chosen. What you also see here is that now all of these files that are in my folder are visible here. So if you just go to Files, you will see all of these here. And if you want to be sure that it's the right working directory, which I can assure you will be, but just in case, you can again just use getvd, and it will tell you that you're in the Peer Club R series folder. Okay. So if you have the setvd in your script, that's already great. You can basically just run that and it will set your working directory for you. Or you can just avoid that by creating a project, have everything together, and each time you want to work, just click on the project, which will then open all of this. And when you're done with everything, you can go to your upper right corner where you see the name of your project. And if you click on that, then you can also choose Close Project, and it will close this project and just bring you back to your like normal RStudio. Good. So that was the first part that I wanted to show. And this is important specifically when you want to upload your data, because you have to tell R where to search for the data. And it's the easiest if you already set the working directory to the folder where your data is saved. Another thing that I would recommend you to do, so I will start another R script again. I will now open a new script and use this to write down our code. There are a few things that I would recommend for a tidy script. For example, the usage of sections that you can insert into your code. And there are different ways how to do so. The easiest way is to start your line with a hashtag and then just add a title for your section. So we will just call it intro, let's say. And then what you can do, as I showed in the slides, is that you can add either 4 dashes or 4 equal signs, or again 4 hashtags to basically create a section. So I will add 4 dashes here. And what you see here is, first of all, that this small arrow here appears. And also, if you just press Enter and then go to the next line, you will see here that now you have a section that is called Intro. You can also see the same if you go here and just click on that, and it will also kind of open basically something like a content of your R script. And here you will have the names of all your sections. And as I said, each section is basically a line that starts with a hashtag, then you have some title, and then you have either 4 dashes or equal signs or hashtags. You can also have 50 of them. It's just important that you have at least 4. Okay, so you can do it this way. Another way, and I'm just gonna delete this again, would be to use Control, Shift, and R. And this will open this small window where you can just choose a section label. Again, we're gonna just write intro and click on OK. And this will already add exactly what I just did. So it will add a hashtag with the section label and then lots of dashes here, just to basically separate those sections. The way I usually separate my sections is by having another line that just has 1 or 2 hashtags and then just a few equal signs. And then in the next line, I would have something like intro again, and then the few dashes. This will separate your sections exactly the same way as before, but I personally just liked to have this prominent border between the 2 sections, which is given by these equal signs. And now that I'm already talking about it, I'm going to show you a small trick how to do this without having to type the hashtags and the equal signs every time. So I mentioned snippets in the previous video. You can add snippets yourself. The way you do so is that you go to the tools, global options, and then to the code. And then here the last line says enable code snippets. And next to it, you can see the button Edit Snippets. You just go there, and then this whole window opens with all the available snippets currently. And you can just scroll through these, see what snippets are already there. And if you want to add a new snippet, you can just basically follow the structure of the snippets that are already given. So for example, there is one snippet here that is this timestamp one that has all of these dashes here. It has the date here and it has the hashtag. And this is the way how it's written. So I'm going to do exactly that. So I'm just going to copy paste this and put it at the very end. Okay, I'm going to give it another name. So I want to use it as a separator for my sections. So I'm just going to call it SN for section. And instead of having the date inside, I will do it differently. I will remove all of these dashes and I will put another hashtag and then a few equal signs. I like to have certain numbers. So let's say 20. That should be 20. And then this here is a sign for enter. Okay, so it's a slash and then an N, which means enter or new line. And then in the new line, I again want to have two hashtags and then some space where I'm going to put the label for my section and then the 4 dashes. Okay, so this is now how my snippet looks like. And it has the acronym SN. And now I can save this and then just click on apply and then on OK. And then we can see if this works. So I'm going to erase all of this that we already had. So what I just did is that I created a snippet called SN. So you just type in SN, and then you type tab, and it will already show you that this is a snippet. And as soon as this is shown, you just click on enter, and you get your snippet. And I'm really so happy that this worked out, to be honest. And then here you can just, again, add a label for your section. I'm not going to call it intro this time. I will call it packages because this is going to be the first thing that we're going to do today. Okay, so now we have the section packages. Okay, so I mentioned the packages in the talk. These packages can either be downloaded directly from cron, which belongs to R, or they can also be downloaded from GitHub, which is something I'm going to be explaining in some of the next videos. And they can be written by almost everyone. So just be careful whenever you use packages that you play around with them a little bit, that you read the instructions properly, and you really make sure that these packages are doing exactly what you want them to do. I am using packages a lot. I would say that there is almost no script anymore where I do not use any package. So this is a really common thing to do, and there are a lot of packages outside. And I'm almost sure that for every problem that you might have, or for anything that you might want to do in R, there might already be a package outside. I will not encourage you to use packages for every single bit, just because I think that using packages keeps you from learning because you're relying too much on the work that someone else has done rather than just like trying to put a little bit more effort into writing your own code for that. And also, if you write your own code, you have much more freedom. You know what you're doing. You have much more control over it, rather than using a package. So this is just my suggestion, but obviously, as I said, I'm also using packages a lot. The way you can install packages is by either going to packages here, and then you can go on install, and probably you will have the repository cron here, which is fine. And then here you can just add the name of the package that you might need. So for today, we will need the packages ggplot2. Then you can separate them either with comma or with a space, dplyr, and tidyr. So these are the 3 packages that I would all want you to install today. If you encounter any problems, please do let me know. But I do hope that these 3 should be doable and that you should not encounter many problems. But if you do so, just email me or just comment below the video. Okay, so when you have all of these 3 packages here, you can just click and install, and then they're going to be installed. Don't worry if you see a lot of red text in here in the console. This is nothing bad. This might take a few seconds, maybe a minute or something. This is completely normal. And sometimes, even if it's going to be red letters or like letters in a color that you would think might be a warning message or an error, Sometimes it's really just telling you, hey, it's been installed, and just so you know, this is the version that you're currently using, and so on and so on. So don't get too confused by that. You also might have something like a warning message saying that something has been masked from another package. And this will occur very often, especially with packages that are coming from a similar family, because they will all going to be using similar functions. And that's why these functions, whenever you install and then load a new package, might be similar to the functions from another package that is already loaded. And then you might get this warning message that some of your functions are masked from another package. Okay, so much about that. Whenever you install a package, that's done. So you have it installed once and you do not have to install it again, except you maybe want to change your RStudio to a newer version or something like that. Then you might have to install the packages again. But apart from that, install them once and then that's it. That's similar to, for example, applications that you install on your phone. So every app that you install, you basically install it once, but by clicking on an app, you're activating it. And we have to do the same with the packages. To activate the package, or basically to load the package, you can either just scroll in this list of packages and then just check the box next to the package that you want to use. Or, and this is something that I like doing and having it in the script, is that you just use the command library. Okay, so you're going to use the command library and then ggplot2, and you just press enter, and this we're going to load the ggplot package, then library dplyr, and then library tidyr. Some might know that all of these three packages are the part of tidyverse. And obviously you can also just load tidyverse, which will then load all of these packages. But for now, just keep these three, because I've already noticed that some people had big troubles installing tidyverse. That's why I'm not showing it here. And we're rather going to focus only on these three packages today. And that's why we're only going to load these three packages. Okay, now that we've loaded the packages, we can just move on and import our data that you want to work with today. So for this, I will just make another section and call it import data. Really easy. So if you're importing data, you can also do it by just clicking around. I personally try to write code for almost everything that I'm doing in R, just because I find it easier. And I have it in a script. I can reuse it. I can sometimes even open a script, mark everything, and just run the entire code and so on. So that's I'm kind of avoiding to do anything that has to do with moving your mouse. Okay. So to import your data in R, first you have to make sure that your data is in a format that you can load in R. And there are definitely a lot of formats that you can use within R. I could imagine that most of you are going to have their data saved in an Excel spreadsheet. And there are packages that allow you to load Excel files. However, what I'm mostly using, and I can tell you that this is the case for more or less everyone else, are the CSV files. So CSV files can be saved directly from Excel. The difference is that these can't have any formatting, and that these can't have more than just one sheet. So CSV file is basically just one single sheet with your data on it, and it is mostly separated by a comma. I can even show, if you need any help with that, how to do that in Excel, but usually it's really just simple. Whenever you have your data sorted in Excel and you go to save as, you just have to pick CSV, comma delimited, save it like that. And you might be asked a few times if you're sure you want to save it, because you're going to lose all other sheets, and that's totally normal. Just click on yes a few more times and then you're done. Okay. So we're going to be loading a data set called growth rates with Daphnia. And I can show you that this data set is already here in our folder. So it's here. You see it. It's growth rate experiments with Daphnia.csv. And this is great that you already see it here with the file extension, because that's something you will need to add when you're importing your data into R. We can call our data anything that we want. I usually use something like my data or my file, or to keep it really, really short, because this is going to be a data frame, I'm just going to call it df as a data frame. We need the assignment operator here. And then the function that you're going to use here today is the read CSV. When you open the brackets, because we are now in the working directory where your file is saved, what you can also do is that you just insert the inverted commas. And while your cursor is within the inverted commas, you can already press tab, and this will show you all the data there is in your working directory. So if you already know the name of your data file, you can just start typing the first few letters. And if I just type G, I'm already going to get the growth experiments with Daphnia, which is awesome. So I can just press enter, and this will already take in the whole name of the data set. Okay. A similar thing that you can do, and I'm going to show it only in the console, is that you type in dir, which stands for directory, and then the parentheses. And if you run this, you're also going to get an entire list of all the data sets or just files that is in your folder. And then here you can also just go to the file that you want to upload and just mark the name and copy paste it into here. Okay, so these are just small things that you could consider whenever you're importing your data. Here, just to make sure, I will add the separator, which in this case is comma. This might be different for other operating systems. And then I'm also going to add header equals true. This is something that already should be a default setting in this function, but I always like having it inside just to make sure that I'm not doing anything wrong. This just tells R that the first line of your CSV file is containing the header, or basically the names of your columns. Okay, so if we just run this with Control and Enter, for example, then you can already see that your environment now has a data frame that has 40 observations and 5 variables. If you want to look at it, you can also just go to this small symbol that is next to it. Just click on that, and this will open a new window that will show your data. I would recommend to do this always, just to check how your data looks like. It depends obviously on your data set how long this is going to take, because there are always people that would have really, really huge data sets. So this might take a few seconds. But in most cases, this is just something really, really fast, and then you already have an overview over your data. What you can also do, and this is something I highly recommend, is that you check some other things. For example, you can use head and then the name of your data set, so of your object that you just created. And then you can add a number, but you don't have to. But let's just add the number 10. What this is doing is that it's showing you the first 10 lines of your data set. You can also tell R to show you the last 10 lines of your data set. So this will be like that. So head is showing the first lines of your data set. Tail is showing the last lines of your data set. Default is 6 lines, but you can add any number that you want. And another thing that you should check is the structure of your data set, which you can do with str and then just the name of your object. And this is now telling us that the 5 columns that we have different data types. So the species column is a vector that has 2 levels, in this case, Daphnia magna and Daphnia pulex. Then we have the column temperature, which is an integer. And we know that here we have the temperature 15 and 20. So this makes sense. And then we have the 3 columns with the growth rates for each of the food qualities. And here, each of these is just numeric. So this also makes sense. Okay, so now that we have made sure that the data is imported correctly, we can move on. One thing that I like doing before I start doing anything else is making sure that my data is exactly in the format that I need to have to basically be able to calculate summary statistics or to do statistics with it or to plot my data. So in this next part, I will reorganize my data the way that I want to have it. So I'm just going to call this section Rearrange Data. And what I'm going to be using here is a function from tidyr, which is called gather. Just to explain how this works, your data set currently, as we saw, looks like this. We have 1 column that is representing the species, 1 column for temperature, but then we have 3 columns for the growth rate. What I want to have, however, is just 1 single column with all the values for the growth rate, and then 1 single column for the food quality that is going to be a categorical variable having the levels low, medium, and high. So what we're going to do is that from this wide format, we're going to rearrange the data into a long format where we're going to have less columns, but these are going to be much longer because we're just going to kind of glue the things together from the 3 columns and just put all these columns below each other, okay? How to do this? For this, you need both dplyr and tidyr because dplyr brings the pipe operator, which I'm going to show, and tidyr has the function that we need. I'm going to rename this data set into df_long. And what you need is just your current object, which is df, and then the pipe operator, which basically just says, do this with that. So basically do something with the object df. And what we want to do is to gather our data. So use gather. And if you just leave it like this, so your cursor is within the parentheses, you already see the input that you have to put into gather to make this function work. So it needs the data, it needs a key, and it needs a value. Everything else here is not that important. The data is already coming from the f object, okay? And this is kind of already combined with the pipe operator. So you do not have to do anything here. If you want, you might just add a dot and then a comma. And this dot basically stands for the df, okay? And then as a key, we're going to just put food quality. So this is now the name of the column that is going to have those 3 categories, low, medium, and high. And for value, we're just going to add here growth rate. And this is going to be now the name for the column that is going to have all the growth rates. And if you run this, you will see that it says that the attributes are not identical across measure variables and that they will be dropped. What happened here? Obviously, I always forget to do this, but it's good that this is happening because I think it's very fair to show you mistakes that I'm still doing. So if we now look into our data set, what we see here is that something different happened from what we really wanted. So now we have the 2 columns that are called food quality and growth rate, but we also have the species and the temperature in here, which is kind of weird. So the actual important part that we wanted to have starts here, okay? But we kind of lost the temperature and the species column, and at least they're not as they were before. So what I did here is that I just forgot to tell R that while it's gathering the 3 columns that actually have the growth rate of the Daphne in those 3 different food quality treatments, it should not gather the 2 columns, species, and temperature. To tell R not to do so is to just specify minus species and minus temperature, and then run this code again. So there is no warning anymore. But if we now look into the df_long, we see that it has 120 observations. Before that, it was 200. And it has 4 variables instead of 2. And if we now look into it, it all looks cool. So we have the column species and the column temperature, then the food quality and the growth rate. And we see here that basically the growth rates from the different columns have just been added at the end of the first column, which was low. So then we have all the growth rates from medium, and then we have all the growth rates from high. And this is exactly what I wanted to have. And now we can really say that each of these rows is one single observation, because there is just one single growth rate here that, as information, has the food quality, in this case being low, temperature being 15, and the species being Daphnia magna. So this is now a data set that you want to have to be able to work in R properly. So next thing that you might want to do is to calculate the summary statistics of your data, something like the mean and standard deviation. And there are definitely many different ways of doing so. I'm going to show you 3 different ways, 2 of which I would say are kind of old school, and 1 modern way, which is also the way I'm doing it nowadays. But I just find that it's cool to see how all these other options work and how different options can be used for plotting afterwards. So I'm going to make a new section. And I'm going to call it summary statistics. Okay, so what I want to calculate are the means and the standard deviations. And what I want to do here is that I want to calculate the mean for each block of data. Okay, when I say block, what I mean is I want to have a mean for Daphnia magna, 15 degrees, low food quality, and then a mean for Daphnia magna, 15 degrees, medium food quality, and so on. To do that, as I said, you can choose between different options. The ones that I'm going to show today are using the function tapply, using the function aggregate, and using the function summarize, which is from the dplyr package. Before I do so, I'm going to show another thing that is not important while you're calculating the summary statistics, but it becomes important afterwards when you're plotting your data. I'm going to quickly go to the section before and just show you the structure of this data set. And if you look here, we see that the food quality here is a character. I will, however, change this into a factor. And this is really easy. So you just type in df_long and then the $sign and food quality. So basically, whatever I'm going to do with the food quality is just going to be resaved again in the food quality column. And then the assignment operator. And then the function that we need is sFactor, but you can also just use factor here because we're going to be rearranging the levels of this factor. And here, what you need is first to say which column you want to coerce into a factor, which again is just the df_long and then the food quality. And then you can add the levels. As you probably can remember from before, the order of the levels is usually an alphabetical one. However, what I want to have here is low, medium, and high. So I have to tell R that I want this specific order of my levels. And how I do that is that I just say levels equals, and then I use C for a vector, and then the parenthesis. And then I just add the names of these levels, which we know are low, medium, and high. Here, it's really, really important that you do not do any spelling mistakes. And just be aware that you should not have any spaces here. If there are no spaces in your actual data set, you should also have the capitals because we're using the capitals in the data set and so on. If you do any mistakes here, you will basically erase any of the levels that you have mistyped so that that will occur as an NA. So please don't do that and just make sure that you're typing this properly. Okay, so if we do that, and then check on the levels of the column food quality, we get exactly that. So we have low, medium, and high here. Okay, good. So now we can continue with summary statistics. So as I said, the first option is to use the function tapply. I'm going to save these means into an object that I'm just going to call means1, nothing special. There are different ways how to do this. I'm going to show you one that is just saving you some typing. You start with the function width. The function width basically just tells R it should use a specific object and do something with it. This saves you from writing something like df_long $, blah, blah, blah. df_long $, blah, blah. Okay. In this case, you just have to say once that you're going to be working with df_long, and then just add your function without having to repeat df_long any more times. Okay. So here we're going to use tapply. And you already see here what tapply needs. It needs x, which is basically your variable for which you want to calculate something, in this case, the mean. It needs an index, which is the grouping variable. So in this case, you want to have species, temperature, and the growth rate. And it also tells you to add a function, which in this case is going to be the mean. So if we do that, we just add growth rate here. And then because we're going to have different group variables, we need to kind of add them here. And the way you do that is that you just create a list which is really easy. Just type list, and then within the list, you just type all of these grouping variables: species, temperature, and the food quality. And then outside of these brackets, because these refer to the list, you then add the function that you want to use, which is mean. You can, of course, also use something like x equals growth rate, and then index equals list, and so on, and then fun equals mean. But if you're just keeping the order exactly the way it is in the actual function, you can also just ignore the names of these outputs and just put the names of your variables or the function that you want to use without having to specify what these are really meaning. So if you just run this now, it will create something, and you see it in the environment. And if you want to see how it really looks like, you can just type in means1, and you will get this. We can also check the class of this. And what we get is an array, okay? And you might be now familiar with arrays. If not, just watch the video 2. There is a specific part now that is only looking into arrays. So what we have here are basically 3 dimensions. First are the rows, which are for each of the species. Second dimension are the columns here, which are for each of the temperatures. And the third dimension is then the food quality. So we have basically 3 slices of this third dimension, which stands for low, medium, and high. This was using tapply function. Then there is another function, which is aggregate, which works in a similar way, but you will see that the output looks different. So we're going to call this means2, very creative, of course, and use aggregate. Aggregate is not really giving you a lot of help here, so I'm going to try to get everything sorted, because to be honest, I had to Google some of these things because I haven't been using any of these old school functions in a while now. So again, we need the name of the object here. And I think that you have to just add the name of the variable here as well, basically like this. And then you add the function, which in this case is going to be the mean. I'm just going to write it like this. And then you have to tell it that it should do it by grouping the data in some way, okay? And we want to group our data again by species, temperature, and food quality. So just write by equals, and then you add the list. And you could just add species, temperature, food quality here by using df long $. What we also want is to already specify the name of the columns that you're going to get as the output, because R is not going to do that for you, okay? So if you're going to use the grouping factor species, obviously we want the column also to be called species afterwards. So we're just going to type in species and then df long $species. Then we want to have the column temperature. By the way, these names do not have to be the same as the names of your columns. It's basically something that you can just define the way you want, okay? And if you don't do so, it will only give the names group 1, group 2, and group 3. This is why I'm doing this. And then here we have food quality. And this equals df long food quality. Let's hope this is going to work. Okay, no warnings, that's fine. And we already see that the means1, for example, is here under values, while means2 is under data. So this is maybe already an indicator that we're talking about a different data class here. So you're going to first look into means2 just to see how it looks like. And this is what we get as an output. So you can see that this output is so much different from the one that we had whenever we were using the function tapply. So what bothers me a lot here is that this column that is having the growth rate is just called x. So I'm going to change this quickly. So I know that this is the 4th column, and I just want to change the name. So I'm just going to go into names of means2. And I'm just going to choose the 4th position. I'm just going to add here the label, which is going to be mean G for basically mean growth rate. Okay. And if we now again look into means2, it will look like this. So basically just the name of the column has been changed here. And if we check for the class of means2, just going to give you a second to think what this might be. It's a data frame. Okay, so before that we had an array, but now we have a data frame. Good. And then the last option is using the dplyr functions. For this, you again just need your object. So it's just df long in this case. And then you need the pipe operator. And I'm just going to always go to the next line. So just be sure that the pipe operator is at the end of your line, and then you can go to the next line, and R will still know that this next line refers to the line before. Okay. So first thing that we need to do here is to group our data by species, treatment, and food quality. And you see here again that you do not have to use df long $, because R will know that this is referring to the data set, or in this case, the object df long. Okay. And then the last thing you do here is that you use summarize. And something that is really cool about summarize is that you can do many things at once. So for example, we want to have the mean. Okay, we're also going to call it mean G. And you just type here mean G, which is the name of the new column, and then mean growth rate. And we also want to have the standard deviation, which I'm just going to call SDG. And that equals SD of growth rate. And then you're done. And then you just run this. And you see that you have mistyped something. Obviously, I forgot that we're not talking about treatment, but temperature. Sorry for this. Okay, cool. Now it all worked out. And if we now go to the means here and just open them, we see that this basically looks like a data frame again. It's a little bit, I think, differently sorted than means2, if I'm not mistaken. I'm just going to click into that. Yeah. So for example, in means2, you see here that everything is first sorted by the food quality, then by the temperature, and then by the species. While in means3, everything is first sorted by the species, then by the temperature, and then by the food quality. This honestly does not really play a role, but just so that you're aware that all of these three options are basically giving you the same data, but just in a different order and in a different structure. So we've calculated this, and we can now basically do some plotting. One thing that I just learned, I'm just going to do a new section here, is that doing bar plots, which obviously you should not be doing too often because bar plots are just unbelievably boring. However, they're pretty common still, and that's why I'm going to show you how to do some. Apparently, if you do them in just base R, as far as I understood, and as far as I know, you can only do them if you have two grouping variables. And with the next grouping variable, it all gets really, really messy. Okay, so I'm not going to be showing it for the data that we just calculated. I'm only going to show it for one specific species. So I'm only going to show it for Daphnia magna. If we, however, plot everything in ggplot, here it really doesn't matter. I think you can go up to, I don't know, 3 or 4 grouping variables. And there are just ways how to separate all of these variables so that you can have one single plot that has all of these different means inside. Okay, so bar plot with base R. So as I said, we're only going to plot the means from Daphnia magna. So I'm quickly going to extract the row data for Daphnia magna. And you can do this also again in different ways. I'm going to show how to do this with base R functions. So I'm going to go into long and then use the square brackets. And here we only want to have all the rows that refer to the species Daphnia magna. So what we need is the column species being equal to the magna. And we want to have all columns. Okay. If we do that, then this is the output that we get. Okay. So now here we have only the Daphnia magna. And then we can just copy paste those means from above and just change this part here into magna because we're only referring to this new object here. And we can remove the species from the list because we do not have any grouping factor now for the species. And then if we run this and then look into the means, we see that we only have the means for Daphnia magna that refer to the 2 different temperatures, which are now in the rows, and to the 3 different food qualities, which are in the columns. And if we check the class, we see here that it's now a matrix rather than an array because it only has those 2 dimensions. If you now want to make a bar plot, basically just showing these means, you can just type in bar plot, and then height is going to be means 1. And what you want to have here is the bars beside each other rather than on top of each other, okay? And if you want to have that, you just have to type beside equals true, and then enter. And this is already a plot of your means. One thing that I would recommend to change immediately, just because I really don't like it, is the y-axis. So basically, I just don't like these numbers being written in this direction. So to change that, you can just go again into your function, add a comma, and then last equals 1, and this will change that, okay? This is really a small thing, but it does drive me crazy. So that's why I'm always showing it. Okay, cool. So there are a few things that you want to do with your bar plot. First of all, we see that here we do have those 3 groups that refer to the food quality, but you also have those different colors that refer to the temperature. So we can think that the dark gray bars are representing the mean growth rate in the treatment with a temperature of 15 degrees, while the light gray bars are representing the mean growth rate in the treatment with the temperature of 20 degrees. However, we also want to have this as a proper legend somewhere, okay? So you can add this as well to your bar plot. So I'm just going to go back to the barplot command and just type in here legend equals true. And if you do that, we get a legend. However, this legend is not saying much. It's basically those 2 numbers, which we know is the temperature, but maybe we want to have a bit more information. And also, it is exactly on one of those bars, and we do not want to have it there. We want to have it somewhere else. And also, another thing that I do not like here is that the y-axis here is just really kind of short. We want to have it a little bit higher. Okay, so we're going to add a few more of these things. First, I'm going to add a title. The way you do it in a bar plot in base R basically is that you just add main and then you add a label here. I want to have Daphnia magna and I want to have it in italics. That's why I'm going to use expression. And I do think that this is going to work. I'm going to use bold italic and just write Daphnia magna in here. I'm going to go into the next line here so that it's just a little bit more visible. Let's check if that worked. Perfect. Really happy with that. And then we're also going to change the y-axis a little bit. So we're going to change the limits of the y-axis, which you can do with y-lim, and just add a vector that has the upper and the lower limit. So the lower limit should still be 0, and the upper limit should be, let's say, 0.6, just a little bit bigger, not much. Okay, so we see the axis is a little bit bigger now, and obviously the bars have been like pushed down a little bit. That's fine. And then we want to change the legend a little bit. Let's hope I'm going to get this together. Okay, cool. Arcs legend, and here you have a list, and then you can add different things. For example, the title, which here is going to be temperature in degrees Celsius. And we also want to change the position. So for example, I'm going to choose an X. And this is now tricky because probably you're going to be asking yourself, how to choose an X? Because all of this is kind of just categorical that we see. We're just going to guess and do something like X equals 1. And then we're going to talk about this in a second. And we're going to choose a Y position. And we know that Y goes up to 0.6. So we're just going to use 0.6 here as the maximum. And if we run that, well, we get a legend that is on the height of 0.6. And it's basically the upper limit of the legend. that is crossing the 0, 6 line, okay? But the X value wasn't really chosen nicely, okay? And we chose 1, which here does not fit at all. And I will explain later why this is the case. To do that, I will show you the following. We're going to use this later for something. So this is anyhow a cool thing to do. I'm just going to save this bar plot as an object. And I'm just going to call this object bar pos, which in this case is going to stand for bar position. Okay, I'm going to mark all of this and press Control I. This is something that I've showed in the slides. It's basically making the alignment of your code so that it all looks tidy again. And I'm going to run that. Okay, it didn't change anything on your bar plot, but you see here that it added an object here that is called bar pos. And if we look at the bar pos, we get a few numbers. These numbers are basically the positions of each bar on the x-axis. If we now look into our means again, the first bar here that is given in the row 1 and the column 1 has the position at 1.5 and refers to 15 degrees and low food quality. Okay, so we know now that the first bar is at 1.5. So we know that we can move our legend somewhere else than 1. And let's say we're just going to put it at 2. Okay, so we moved it a little bit. It's still not perfect. And I can tell you whenever you save this, it's going to look different again. So I'm going to just change this a little bit further. Let's keep the, let's say 2.5, but just put it also a little bit more up. Okay, I think I can live with that. I hope you can too. Next thing that I want to do is to add the error bar. And in this case, it should represent the standard deviation. We have so far not calculated the standard deviation using the tapply function. So that's why I'm going to quickly do that. And you can do it the same way as you did it for the means. I'm just going to put this in here and call this SD1. And the only thing you have to change is basically here the SD. Okay. And if we do that, we get the values for the standard deviation. There are different ways how to add the error bars to the bar plot. I'm going to show you the really old school version of doing that, which is something that I discovered at some point, and I found it so funny because it's showing again how you can combine different functions in R that usually would not go together and are meant for totally different things, but are basically doing exactly what you want. Okay, and one of these functions is called arrows. So what I'm going to do is that I'm going to use this function to just create these error bars with the limits on the upper and the lower part of this arrow. And they should be positioned exactly in the middle of each of these bar plots, right? So this is exactly where we're going to be using the object bar pos, because this is telling us where our bars are positioned on the x-axis, okay? And if you look here into the help that is provided by RStudio for the function arrows, you see that it needs the input x0, y0, x1, and y1, okay? These stand just for the coordinates of your plot, okay? So x0 are just going to be more bar positions. And then x1, again, are going to be the bar positions, because these arrows are just going to be drawn basically in a vertical position, and this position is the same for both x0 and x1, okay? And then we're going to add y0. So we want these error bars, or these arrows, to go from mean minus the standard deviation until mean plus the standard deviation, okay? So we have the means, and we have the standard deviation. I'm going to do here, sorry, I'm going to add y1 is going to be then means 1 plus the standard deviation. And then there are a few more bits that you have to add. One of them is the angle. The angle is basically specifying those limits that are at the end of the arrow. This would be something like 45, this would be 30, but we want to have 90. Okay, so we want to have the ends looking like this. So we add the angle of 90. Then you can add a code, and the code here is going to be the code 3. This is basically saying that you want this arrow or this arrow bar to have these small limits at the top and at the bottom. And we're going to add the length of these sticks at the top and at the bottom, which I'm just going to set to 0.1, let's say. And then we can run this, and voila. And that's already done. And that's already more or less the bar plot that you would be even able to submit to a paper. One last thing that you're missing here is just the label on the x-axis and a label on the y-axis, something that I mistakenly forgot to do before. So you can just go back to your bar plot, for example. Just going to put a comma in here. Okay, and just add X lab is food quality, and then Y lab is basically somatic growth rate, and which I'm also going to write like that. I would also always recommend to add the unit here, which in this case would be per day. But because I would have to use an expression here to basically specify day and then the subscript -1, I'm just going to ignore this quickly, not to make this too complicated. Just leave it like that. That should be fine. I'm going to run this again and then run the errors again. And that will be it. Okay, so this is already a plot that you could use. One big mistake that many people do whenever they're done with their plot is that they export their plot by using the export option here. Don't do that. I will show why. So for example, I will save this as an image and as a PNG, that's fine. And I'm just going to use here 640 and 480. Update the preview. Looks like that. Well, it's not fine because of the temperature here, but I don't mind. Just going to leave it like that and just save it. Okay, and it's going to be saved in your peer club series. Oh yeah, we're going to call it rplot1. Okay. The way I would recommend to do this is, in this case, to use the function PNG. The way this works is that the PNG function opens a window, and then you plot all your stuff into that window, and then you have to close that window. Okay. Because you have to plot into the window, obviously you have to call this function before you plot something. Okay. So to do this, you would have to place the command before you execute a bar plot. Okay. So you're going to start here with PNG and then give it a name, just rplot2, and then add the file extension, which is PNG. And then you can choose a specific width and height. You might have to play around with this. So whenever you just save it, look into your plot and then see if it all looks nice. And if not, just come back, adjust it again, and run the code again. I'm going to do this in centimeters because that's how I basically work better. I'm just going to try something like 15 centimeters for the width, and then let's say 12 centimeters for the height. And to let R know that you're talking in centimeters, you have to add the units here because the default units are the pixels. So you add centimeters, and then there is another argument that you can specify here, which you can't specify when you're using the export option in RStudio, which is the resolution. So you just set the resolution to, let's say, 600. Okay, good. Nothing happened. At least that's how it looks like for you. However, I'm just going to demonstrate something. I'm just going to erase all of this. Okay. And I suppose that's what you expect, is that if I would run this, you would automatically expect to see it again in this plot window here. This is, however, not the case, because now we're plotting the bar plot into the PNG window, okay, which is opened in our folder for which we have set the working directory. Okay, just going to remove this because we don't need it here. And then I'm going to run the arrows. Okay, and then I'm going to close this window because now I'm done with the plotting. To close the window, which also can be termed device, you just use dev off and then the parentheses, and then you're done. Okay, and it will tell you here that it saved it into the PNG4. I do hope that this worked now. So if we now go to our folder where you have your files saved, just going to see if I can maybe even access it here. We called it rplot2, and we have it here. I don't know if you see that. I see it on my computer, but I'm not sure if you're sharing it. However, if you click on that, you're going to see your plot. I will ask you now to just zoom into your plot, okay? Just zoom into it, and you will see that the quality is pretty good, okay? So it's not pixely or something whenever you zoom into it. You might notice that your temperature legend looks awful and it's a little bit misplaced, and you would have to play around with it a little bit more. But apart from that, the plot really does look nice, okay? You can solve the problems with the legend by maybe changing the size of the font, something that I will do in a second, or you can just adjust again the width and the height of your plot. So I'm just gonna show this just quickly here. So as I said, you can change the size of the font. We're gonna change it here to 0.6, and then we're gonna just run this entire thing here, and then check again on our figure. And now the temperature legend is much smaller, and at least on my computer, it looks like it fits into the plot without overlapping with anything else. And in general, the plot looks nice. Okay, so this was plotting a bar plot in base R. And now I'm gonna show how to do this in ggplot, and then we're gonna be done for today. Again, a new section here, and we're gonna call it bar plot in ggplot. Okay, so here, the cool thing is that we can even use the means that we've calculated for the entire data set, which includes the species and the temperature and the food quality. And I will show you how to basically separate these into different panels. I'm not going to talk about too many details here because I'm going to give a specific section on plotting in ggplot. So these are just going to be a few basics. How you start developing your ggplot is by just typing ggplot, okay? And then here in the parentheses, what I usually do is that I already put in the data and the variables that I want to plot. So we're going to be using means3 because this is what we've calculated using the dplyr functions, okay? So this is the data. And then you see here that it says mapping equals to AES, which stands for aesthetics. So we're going to add this, and we're just going to say that, let's say, X is going to be temperature, okay? And then Y is obviously our measured variable, in this case, the summary statistics mean. So we have mean G here. You can also add some other statistics for other grouping variables, but you can also do the same later on when you add the geometrical objects to plot. So what you can do here is just add a plus and then go to the next line, and then we can already add here the geom bar. What you need to add in the geom bar command is, first of all, stat equals identity, which will tell R that it should indeed use the values from the object means3 rather than making counts out of these values, okay? So this is something you should not forget whenever you're plotting a bar plot. And then you can specify things like the width. And then one thing that I'm not going to be demonstrating how to do by just plotting these and then showing you what's wrong, I'm just going to say it right away, is that you have to specify a position here, because again, you want to have these bars to be beside each other rather than on the top of each other, because currently we are only subdividing these bars into the different temperatures, okay? So to do that, you have to add position equals position dodge. And you just add a number here, and I think pretty much everyone uses 0.9. That's kind of a standard. And then what you can add here is the color of the border of the bar and also the color for the background of the bar, which can be specified using the argument fill. You can either specify these to just be one single color by just adding the color here, or if you want these colors to differ for a specific grouping variable, then again, you have to use the argument aesthetics first, okay? So aesthetics is always used when you want to have a certain variable depending on your object. So in this case, you want to have the variable, for example, food quality, specifying the color of your bars. In this case, the background color. So we're going to set fill to equal the food quality. But we're not going to be changing the color. We're just going to leave color at black in this case. Okay. Good. And then don't forget that we're still having another level of grouping, which is the species. And I will show in a second how to specify that. So I will first run this just to show you how it looks like. And what you see here is that, first of all, we have this very weird x-axis, which basically is correct because R knows the temperature is an integer. So it would expect to have a continuous x-axis. However, we do not want to have that. We just want to have it as a categorical variable. So I'm going to change this in a second. And then you see that these bars all look like they are containing 2 bars rather than just one single bar. Okay. And this is because we still have this level of the 2 different species that we haven't incorporated into the plot. Okay. So the next thing that I'm going to do is to change the temperature into a factor and also to tell R that it should basically make different panels for each of our Daphnia species. To do so, you can go to a temperature. You don't have to change it in the data set. You can just do it directly here and just write S factor temperature. Okay. So this is one thing, and I'm just going to run this to show you how that looks like. Okay, so this already looks like different, and this is fine. So that's exactly how we want to have it. And then we're going to add facet wrap here. I think it's facet wrap, but I already got so used to saying facet. So just bear with me and just ignore my English in this case. And here we want to subdivide those panels by the argument species. And if we do that, then we get this. Okay, so now we have 2 panels, one for Daphnia magna, one for Daphnia pulex, and they're both having 3 bars for each of the temperatures. Okay, and these bars are all colored differently because they're coming from low, medium, and high food treatments. Next thing you want to do here, just to be sure that we have all this information that you also had in the bar plot produced in the base R, is that you want to add the arrow bar. You can do that by just adding a next geom, which is called arrow bar. And again, you have to put everything into the aesthetics argument because it's again referring to your data. Okay. And what this command here needs is ymin, which in this case is just your mean minus the SD. And then it needs a y max, which is mean g plus the SDG. And then you can basically move your cursor out of these parentheses. And then you can add any other things that you want to have. I'm going to leave the color to be black, which I think is also the default. So I'm not going to change anything about that. But one important thing that you have to add here is the same position argument as for your bars. So I'm just going to copy paste this into here. So this will tell R to basically put those arrows exactly where the bars are. And I'm just going to add the width, which is the same as the length in the arrows argument. And I'm going to, again, choose 0.1. And we can still adjust that. I'm going to run this. And it didn't work. So this is something very specific that I will be explaining in the ggplot workshop at some point. But I'll have to mention it here now that it occurred. Obviously, the bars here are also separated by the grouping factor food quality. Okay. And the way this is done is by using the fill argument in the geom_bar command. What you can also do, and I'm just going to demonstrate it now, and I'm really sorry if this is going to be confusing. I'm going to do a much better job in the ggplot video. I'm just going to take this out, okay, and just going to put it into the very first line. And just going to remove this part here. And now R knows that whatever happens in this plot here, that all of it refers to an x variable, which is temperature, a y variable that is mean g, and a fill variable, which is the food quality. And if we run this now, we get exactly what we wanted. So these are the small things that I wanted to show. And obviously, as I said, I'm going to go into much more detail in a specific ggplot workshop. But this is just for you to see how it all works and what are the common mistakes. and how to solve them. Okay, so this is now exactly the plot that we want. You can still change a few more things. I'm just going to add a few more small bits. For example, this gray background is just awful, so we're going to get rid of that, which you can do with team BB, which stands for black and white. And we're going to remove those panel grids. So it's just team panel grid equals element blank. Oh, sorry. Okay, this looks much nicer now. One other thing that I'm going to add are nicer labels for the Y and the X axis. So you can add labs in different ways by either using xlab and then just add the name, or you can also just use labs and then specify X to be temperature here in degrees Celsius and Y to be somatic growth rate. Okay, that's really easy, and I think that's already more or less fine. And one other thing that I do not like are the colors. First thing, and the second thing is that these bars look like they're levitating, and I hate that, to be honest. So we're going to change that as well. So we're going to first change the colors, which you can do with scale fill, and then you can either choose the brewer if you want to specify a specific set of colors, so a specific palette, or you can just use something like manual and then just add specific values that you want to have. We're going to keep this grayscale. So I'm just going to add a few gray colors here. And then gray, and then gray 80. So they're in different grayscales. And then we're going to change this Y scale and just add scale Y continuous and say that we still want to keep the limits to be 0 and 0.6. That's fine. But then we do not want those axis limits to be extended. Okay, so we can just specify the expand argument, which is again a vector, and we're going to just put 2 zeros inside and run this, and that's it. So this is now the bar plot that we have created with the ggplot. Some might find this much more complicated. I find it easy just because I've been working with this for so long now. And for me, most of these things are just very, very logical. You can obviously choose whatever you want to do. Whatever works the best for you, go with that, as long as you are sure for yourself that whatever you're doing is correct. That's the only thing. If it works and it's correct, go for it, okay? If you need any help with that, let me know. I will just quickly going to show you how to save this plot. Again, different options, but ggplot has a specific command to save the PNG files or even PDF files. And we can just set here gg save, and then you first add the name, and we're going to just call it rplot3, nothing special again. And then you add the name of the plot. So we're just going to call this G. We're just going to save this into an object, which is not going to show you the plot again. So I'm going to demonstrate this. If you remove all of this and run this and save it as an object, it's not going to show the object here, but it's going to have the object in the environment. If you want to see this plot in the window, you just have to press G again and run it. Okay. And then we're going to add G here. And then again, let's say width 15 and height 12. You do not have to specify the resolution. I think it's already specified. You just have to specify the units, which are the centimeters. And then if you want, you can go to files, and then you will see that you have another plot here, which is the rplot3. And if you click on it, then you should have the plot. It looks a little bit squished because the legend here is on the right side. So it's kind of taking a little bit of space. If you want, you can change that. You can either put the legend on the bottom, which I will quickly do for you. So I'm just going to say here, legend position is going to be bottom. Going to run this and then run this. Okay, so now it looks like that. And if you run that again and then check on this, the plot will look much, much nicer. Okay, so that was it. Obviously, now you can save your script if you haven't done so. So I'm just going to call it here my first R script. Okay. Now it's saved. And if you're done with everything that you've done for today and you want to erase everything that you did and just make sure that nothing anymore is in your environment, then you can just go here, erase everything, and you're done. And then the last thing you can do is to close your project. So you go in your right upper corner, go to your name of the project, close project, and this will ask you again if you want to save the history, I think, or the workspace. You just say no and not save, and then you're done. Cool. So that was it. I hope you enjoyed that. It got a little bit longer again than I wanted it, but this is now your first R script. You've learned how to import your data, how to calculate the summary statistics in different ways, and how to plot in both base R and in ggplot. If you have any questions, as always, just post your questions under the video in the comments or send me an email or anything, and I will be very, very happy to come back to you. See you at the next video. Bye.